In this video, we will look at the double angle proofs part of trigonometry for grade 12. Now, you guys know that there are two double angles that you work with, the first being sine 2 theta and the second being cos 2 theta. Our aim is to work through the derivation to see exactly why sine 2 theta is equal to 2 sine theta cos theta. Now, let's start off with the left-hand side where we have sine 2 theta. And the first step is to break up 2 theta as theta plus theta. Now, the reason why we're allowed to do this is because theta plus theta is 2 theta. So what we've actually done is we've compounded the right-hand side. And that is extremely important for you guys to take note of, because compound angles is also something new in grade 12. Now, this right-hand side is in the compound angle format, sine A plus B. That has its own expansion, which is going to be sine A cos B plus cos A sine B. So this is exactly how we are going to expand sine theta plus theta. So according to that, we are going to have sine of the first angle, and our first angle here is theta. So it's going to be sine theta. Cos of the second angle, and our second angle here is theta as well. So it's cos theta. Then we've got a plus in the bracket, so we're going to keep the plus in between. Then it is cos of the first angle. So cos theta times sine of the second angle, so times sine theta. Now, you guys, at this point, you should notice that both of these terms are exactly the same. And why they're exactly the same, even though the second one has cos and then sine, we can actually swap those two around to make it sine theta cos theta, since they are being multiplied. So I am going to keep the first term as is, and for my second term I'm going to write it as sine theta cos theta. Okay, so maybe this can help you to see that they are the same. And now that we have two like terms, we are going to gather them. Sine theta cos theta plus sine theta cos theta is going to give us 2 sine theta cos theta. So we have proven that sine 2 theta is equal to 2 sine theta cos theta. It is a fairly simple proof. All you need to remember is that you are going to compound this as theta plus theta, apply your expansion for the compound angle, and gather like terms. We're now going to look at the proof for cos 2 theta, and you guys know that cos 2 theta has 3 different expansions. The first being cos squared theta minus sine squared theta. So let's focus on that first. We're going to start off by saying cos 2 theta is equal to, and we are going to compound this angle. So just like what we did with sine, we are going to write this as theta plus theta. Now, it's important to take note of that format. We have cos A plus B. And the expansion for cos A plus B would be cos A cos B minus sine A sine B. So that is the format that we are going to use to expand this. Now, it is cos of the first angle times cos of the second angle. And in this case, both our first and second angle are both theta. So it's going to be cos theta times cos theta. Now, if there's a plus in the bracket, then we have a minus in between the terms. So we're going to have a minus, and then it is sine of the first angle times sine of the second angle. So here it's going to be sine theta times sine theta. Now, to simplify this, in your first term, you've got cos theta being multiplied with itself. So we can write that as cos squared theta. Then we have a minus, and we've got sine theta being multiplied with itself. So that is going to be sine squared theta. And at this point, we have proven that first expansion. So we have proven that cos squared theta minus sine squared theta is equal to cos 2 theta. Now, let's focus on proving the next two. So the next one I want to prove is 2 cos squared theta minus 1. And in order to do that, we are going to just continue from this expansion. The next thing we're going to make use of is an identity which you guys learned last year. Sine squared theta plus cos squared theta is equal to 1. Now my aim here is to replace sine squared theta. So in this identity, I'm going to make sine squared theta the subject by taking the cos squared theta over to the right hand side where it will become negative. So since this is going to be used to get the next expansion, I'm just putting an arrow to show you that it could go one of two ways. Where the first way is that we are going to keep the cos squared theta there, and we are going to replace sine squared theta with 1 minus cos squared theta. Next, we are going to take that negative and multiply into the bracket with both terms. So we have negative 1 plus cos squared theta. We are now going to gather like terms. So cos squared theta plus cos squared theta is 2 cos squared theta minus 1. Notice how this now matches that second expansion. So what if instead of the first two, they had asked you to prove that cos 2 theta is 1 minus 2 sine squared theta instead? So let's see how we would do that. We would still need to get to this point where we have cos squared theta minus sine squared theta. But from there, we're going to go in a slightly different direction. We are still going to make use of this identity, but now what we're going to do is we want to make cos squared theta the subject. So to manipulate this, I'm going to take the sine squared theta over to the right hand side. And to continue from this last step, I am now going to replace cos squared theta with 1 minus sine squared theta. Next to that, I've got a minus sine squared theta. I am now going to gather like terms, and I get 1 minus 2 sine squared theta. And that gives me the third expansion. So notice how, for you to get the last two expansions, you have to use the first expansion. So you have to work from there. I'm just going to put an or in between this to show you that it could go either way depending on the expansion that you need to prove, okay? But you will always get cos squared theta minus sine squared theta first. And from there, you will use your identity, manipulate it to get the expansion that you need. So that is the proofs. They are fairly simple. All you have to do is know how to work through them. You need to memorize them and be able to replicate it in your exam.